students, I prepared problems that I know will help you in your study of hydraulics. So, class, this is another sample for flows in orifices. Okay, so orifices, kamukha nito sa figure na to. In the figure is shown two chambers, two tanks. Okay, this tank is discharging towards the other tank through an opening, para yung butas. The diameter of that orifice is given in problem A, which is 5 centimeters. Now, the height of the fluid inside this tank is 5 meters. P1 and P2 will be is given as 0. So, let us assume that the tanks are open tanks. Okay? So, you are required to find the theoretical velocity, the actual velocity, and the actual discharge Q. So, these are the given. So, the pressures at 1 and 2 is 0. Again, open tank. H, the height of the fluid inside this tank is 5 meters. The diameter of the orifice or the opening discharging through the other tank is 5 centimeters. The coefficients of velocity and coefficient of contraction is 0.62. So, let us solve. Okay? To solve for the theoretical velocity, from C sub B is the ratio of the actual and the theoretical velocity, we can find the theoretical velocity as the square root of 2gh because from our discussion of energy or head, the total head produced by velocity is b squared over 2g. So we solve for b sub t, the square root of 2gh. So remember, when the head is given, if you use this formula, the velocity is theoretical. The velocity is theoretical. So we just substitute square root of 2gh, square root of 2 times 9.81 times 5. The theoretical velocity is 9.9. And then we go back to the formula. C sub B is the ratio of the actual to the theoretical. So alam na natin yung C sub B. Given siya as 0.98. Theoretical velocity is 9.9 meters per second. So we just substitute and solve for V. The actual velocity is 9.7. Okay? And then, nasolve na natin V sub T and B. We solve for the actual discharge. Now, the actual discharge, okay, from the ratio, the definition of C, which is the ratio between the actual and the theoretical discharge, the actual discharge is CQT, okay, CQT. Now, C can be computed because C sub C and C sub B are both given, so the coefficient of discharge is 0.61. Now, from here, 0.61 times QT. So, what is QT? The theoretical discharge is the area of the orifice, yung dinaanan ng flow, ayan. So yung flow natin is passing through a circular opening whose diameter is D and B sub T. Okay, B sub T. Alam na natin yung B sub T, it's 9.9, and the area of the orifice in terms of its diameter is pi d squared over 4. So we solve for Q sub T, the theoretical discharge, which is 0.019 cubic meter per second. Now, we substitute this quantity C and QT in this formula. We solve for Q is 11.8 liters per second or 0.0118 cubic meter per second. So, changing our problem, changing the conditions of the problem, that is, there is now pressure at 1, at tank 1, which is 70 kilopascal. The pressure at 2 remains 0. The height of water, the height of the fluid inside tank 1 is 1.6 meters, and the fluid has a specific gravity of 3. Okay? And the coefficient of discharge and velocity is both 0.95. The opening has a diameter of 7.5 centimeters. You are still to determine the theoretical the actual and the theoretical velocity, the actual velocity, and the actual discharge. So, to find the theoretical velocity, this is the formula. Again, you use this formula. V sub t is the square root of 2gh, where h is the head that produces the flow. Now, the head now is not only the height of the fluid, but there is pressure. There is pressure in the tank. And the pressure is 70 kilopascal. So, the unit weight of the fluid is 3 times that of the unit weight of fluid, water. So, the total head now that produced the flow is 3.98. The height of water and the pressure head. Okay? So, V sub t, okay, is the square root of 2gh. This is now the capital letter H, the total head. So, we just substitute. The theoretical velocity is 8.84 meters per second. And then, since we know the theoretical velocity, C sub B is given, so the actual velocity can be computed as 0.95 times 8.84. So, the velocity actual is 8.39 meters per second. Now, so, pwede na rin. Madali na ngayong compute ng Q kasi from the ratio of the actual Q to the theoretical Q, we solve for the actual discharge. Area is the area of the opening. V sub t is given. We have already computed that. So, we obtain the value of the discharge, the actual discharge as 0.037 cubic meters per second or 37 liters per second. Okay. Another sample is given in this problem. Let us read. A calibration test of a 12.5 mm circular sharp edge orifice in the vertical side of a tank showed a discharge of 590 newtons of water in 81 seconds at a head of 4.7 meters. The measurement of the jet showed that it traveled 2.35 meters horizontally while dropping 30 centimeters. And you are required to determine the 3 coefficients: discharge, velocity, and contraction. Okay. So, let us show the solution by first drawing the figure that is related to the problem. So, sabing ganon, this is the tank, and the tank is discharging through an orifice. Okay. Through an orifice that is 12.5 in diameter. So, it discharges. So, ang discharge niya is a jet that is projectile. Projectile siya. So, from the orifice, the head is 4.7 meters of water. So, water ang laman ng tangke. Sabing ganon, the jet that is issued from the orifice traveled 2.35 horizontally while this jet is dropped 0.3 meters from its source to the probably to the ground. Okay. So, solving for the first coefficient, ang binigay kasi dito is the actual discharge. Okay, kasi if you remember, ang sabi ko, all the quantities that are measured, quantities that are actually measured and actually weighed, tinimbang ng actual, these are actual quantities. So, the actual discharge through the orifice is weighed. Tinimbang siya, 590 newtons sa loob ng 81 seconds. So, this is the actual Q, the actual discharge. And how do we find the actual discharge? Since we know that the discharge is cubic meter per second, volume per unit of time, we have to find the volume. Gaano ba yung volume na occupied by 590 newtons of water? So, we know that from yung unang-unang lesson natin, unang-unang unit natin, mga fundamental quantities, the unit weight is the ratio of the weight over volume, kilonewton per cubic meter. So, the volume can be computed as the weight over the unit weight, and the unit weight is that of water. So, the weight is 0.59 kilonewton, 590 newtons yun, so 0.59 over 9.81 kilonewton per cubic meter. Yung volume na inoccupy ng 590 newtons ay 0.06 cubic meter. Okay, that is the volume. And then, so the actual discharge is 0.06, yung tinimbang na tubig, 0.06 cubic meter over the time that elapsed para maka-discharge ng 590 newtons is 0.74 liters per second. Yun yung actual. Kasi, nanggaling siya sa tinimbang na quantity na dinischarge through the orifice. Okay? And the theoretical discharge is using the head, square root of 2gh. The head is 4.7, so yun, 1.18. Now, the ratio of this actual and the theoretical discharge is computed as 0.63. That is the coefficient of discharge. Okay, so in letter B, the coefficient of velocity, again, is the ratio between the actual and the theoretical. Now, what is the theoretical velocity? That is in terms of the height of the fluid or the total energy that produces the flow. In this case, it is only the height, which is 4.7. So, you just substitute directly. The square root of 2gh is 9.6 meters per second. Yun yung theoretical in terms of the head. Now, the actual velocity can be, sabi ko nga, weighed, sinukat, tinimbang. Yun ang mga actual. Kasi actual mong nakuha yung mga values. So, ang sabi nga sa problem, the jet drops 0.3 meters while it travels horizontally 2.35 meters. So, dun sa figure natin kanina, x is 2.35 and y is 0.3. Dun sa figure. Now, if you recall your physics, for the horizontal distance can be computed by multiplying the velocity times the time traveled. Okay? Then, a freely falling body will be traveling a height of y, which is equal to 1/2 gt squared, because it is acted upon by, it is pulled by the acceleration due to gravity. So, 1/2 gt squared. So, from this formula, and we solve for t is equal to x over v, and t squared is 2y over g. If we square this becomes t squared is x squared over b squared. Now, these two equations are both in terms of t squared. So, we equate 1 and 2. In-equate natin yun. T squared is equal to t squared. So, t squared is x squared over b squared. The other t squared is 2y over g. So, we solve for b. So, the actual velocity v is the square root of x squared g over 2y. So, yun ang binigay sa atin sa problem. It travels 2.35 meters horizontally while dropping 0.3. So, isa-substitute lang natin doon. So, ito na yung actual. 9.48 meters per second. Actual yun kasi itong mga values na ito ay sinukat. Okay? Actual na sinukat. So, ito ay actual quantity. So, substituting to the formula for finding the coefficient of velocity, the theoretical velocity and the actual velocity, ang ratio niya is 0.988. Okay? So, we can readily solve now for the coefficient of contraction. That is the ratio between the actual discharge and the ratio between the coefficient of discharge and the coefficient of velocity will give us C sub C equal to 0.634. Thank you for watching my YouTube videos. See you next time!